We should be live. Yeah, everything seems to be working good. Hello, everyone. I guess I should actually open my code thing. I have so many hard drives. How do you hide these? I haven't used Linux in a while, so. Oh, what? OBS doesn't give me the chat? Really? Really, OBS? I mean, also OBS might not be updated, so. Alright, well, hopefully all my settings are working fine and whatnot, but I guess while I wait, I can just run this. So I've been learning OpenGL and ray marching along with that. OpenGL just, it feels so much easier to use. I feel like graphic stuff makes a lot more sense to me now while using OpenGL. I don't know. It just that's kind of how it is. OBS doesn't integrate with the stream on Linux or something. Like I don't understand what's going on here. Where's my chat and stuff? Does it not do that on here? I guess not. Okay. We will just pop out the chat then. And we will put this always on top so I can just always see it, because otherwise I will not see it and I'll forget about it. Actually, can I like make this small and just kind of put it here? Oh yeah, I forgot I'm on Linux. I can just like grab a window anywhere and just move it, like without like clicking on the things in the window. Oh my goodness. Ah, Linux. I love it. I miss this so much. I just feel so comfortable on Linux now. Okay. Let's see. This is now on the way. I am live. We need to let the peoples know that we are live. I am live. Please watch. Yeah, I was trying to. Trying to get things kind of set up still, because I haven't really used Linux in a while, so I'm a little just trying to figure stuff out here. Okay, so back to this. Yeah, I've decided that maybe I should rewrite the whole falling sand thing in OpenGL, and I want to use ray marching as the method of rendering. It seems like it will be the best option. It's also pretty simple. I mean, this is entirely ray march. This is only 2 triangles, so yeah. I was going to try and install JetBrains Sea Lion, but it seems like it could be a little bit of work. Can I open with VS Code? Here we go. There we go. Let's stop this. Okay. So hopefully everything's working fine, and hopefully I'm actually using my GPU to record. We hide this. Is it like Control J? There we go. Installing Sea Lion. where you wish to install a program. To start the application, open a console, cd into the bin folder, type cline sh. This will initialize various configuration files into the directory. Add the bin to the path. Okay. So actually it's pretty easy. I just need this. And where is it? Can I open in the terminal? And Sprice is not just an option for it. Really? Oh, there it is. I'm not thinking. Right. In order to paste, you need to do that. That should work. Yeah, let's go. We got cline. Okay. Nothing against Visual Studio Code, or VS Code. I'm just not used to it. I'm gonna be honest. So why does control scrolling not? Okay. But if I can have cline running, that'd be great. Sure. Activate. Can I log in? Okay. Let me log into this real fast. Can I just sign in with GitHub? Authorization successful. Okay. Move OBS back over here. Doesn't look like it really worked. Let's try that again. Oh, there we go. Continue. Okay. Input. Please consider disable input methods if you don't really use them. I mean, okay. Let's open for version control. And actually, what I want to do is, I have this 2D falling sand. I don't want to rename the repository. It's not a great idea. This is the repository I was using for the 3D. Originally it was the 2D, but I converted it to 3D. I think I'm just gonna leave this alone. I'll probably update the README of all my repositories to point to the actual 3D falling sand simulation repository, which is this one. Archaea is what I call it. The thing is, this is in Rust, but I'm just gonna wipe out all this code. I'll create a new branch and just wipe it all out and replace it with C, or C++, I should say. Let's see. Okay. Okay, let's see. Actually, I can just log into GitHub, authorize. So you're gonna dox me here? No, okay. Yeah, okay, so I can just clone that. Can I clone this to dev slash, there we go. I wish that I could actually work with my sharing as caring to drive, but every time I try to open stuff in VS Code in my sharing as caring drive, it would not work because of permission errors that I don't want to even try to deal with. Trust project. Okay, full screen. Now the thing is, this is in Rust. Let's let this load. Okay, so the thing is there's not gonna be any configuration right now. Let's go ahead and create a new branch. We'll just say rewrite 1. Shall we? Yeah. We gotta name it something better. Using C++ now. It's a horrible name. Screw Rust. Yeah. I'm not very good at naming branches. We'll just call it rewrite 1 for now. Alright, we're in the branch, and now what we can do is just delete all of these. Yeah. WSGL. Yes. Let me just delete everything in here because we do not need it. Actually, leave the git ignore, that's fine. The GitHub, that's the workflow. We'll remove that. And, okay, let's create a new main.cpp. Add, configure, create CMake, use include directories. Sure. I don't know what that option does, but you know. We don't use you, AI assistant. Sorry. We're not using C language standard. That's too much. Okay. We'll start with this. We'll do int main void return 0. We can standard cout hello world standard end line import from the same place. Okay, and this is complaining redundant void argument. Fine. New line, and then if I run and everything just works. Yep. Okay, we got everything set up. Okay. Unversioned. We're gonna want to git ignore the CMake build debug folder, the CMake build release folder as well. Yeah, that should be fine. Initial conversion to C++. I'm surprised that's worked so far. Let me move the chat over so I can actually see it and not like forget that it exists. Coding streams. Oh, perfect. Yeah. Hopefully I get some viewers. That would be great if I did. I highly doubt I will, though. Let's see. I have so many things open. No one's viewed. Hopefully, all my stuff's working. I guess I never actually really configured yes. Advanced audio properties. Let's see. One of the main things is I'm gonna start doing all my Minecraft streams in Linux because audio and actually do what I want to do with audio, but that's the whole other thing. This is a programming stream, not a audio stream. I do need to add my filters back. Let's see, limiter. Yeah, let's see. That should be fine. Yeah, we're configuring OBS stream midstream. Okay. Let's see. Threshold, that's fine. Even if I talk really quiet like I sometimes do, then, you can kind of hear me. Okay. Let's see. We want to add a noise. Open thresholds too much, in my opinion. Even if I talk a little quiet. Because I talk a little quiet sometimes, you want to be able to hear me when I'm talking. You don't want it to cut out and I kind of like mumble. You know what I'm saying? Okay, I gotta stop mumbling. That's kind of weird. We also want my mouse to stop freezing. Noise suppression. I think I'm gonna plug my mouse in. It might be almost dead. We should probably do that first. Good quality noise suppression. I don't think I really need anything else. I'm not gonna be really like shouting, so I probably actually don't need a limiter. My mouse keeps freezing. Oh, I removed the wrong. Okay. Noise gate and noise suppression. Thank you. Okay, you know what? We're gonna just pretend that it's not broken right there. All right. I might need to turn up my mic a tad bit. It is looking a little quiet. Let me plug in my mouse because it's laggy. Mouse. When my mouse starts to lag, it means it's almost dead. I've never had it lag on me when I use when I use the Bluetooth with it, and it's almost low battery. But when I use the dongle thing, it starts to resent. So wire. Work with. There we go. Okay, let's actually start doing some OpenGL code here. Can I configure CMake lists? Alright, I'm gonna open this because this is kind of my like demo project here. So what I have, I'm gonna kind of copy this. Um, I can go over what this is doing, but we're gonna copy this and then replace the project name with the proper project name. Yeah. Let's see. C standard, main C++, copy shaders. That should be alright. And then I don't think we actually need to do anything else. Reload. Let's see. Cannot copy shaders, right? Directory, shaders, and we're going to need, for now, we're going to just make a vertex dot vertex. I don't know if install plugin. It'd be nice to have some plugins. I also probably need to change the theme because I'm not quite used to that. Is it gonna install? Yes, okay. We'll deal with that in a minute, and then a new okay, new file, and we'll call this pixel. Yeah, pixel.glsl. I guess I should call the other one GLSL. I mean, it doesn't really matter, but GLSL. And then when cmake runs, it should automatically just copy the shaders folder here. Yeah. I don't know why it does that. I don't want that. Okay, there we go. Cringe, cringe, cringe. Okay, let's see. I do need some water. Hold on. Okay, what does this cmake list file do? This is the cmake minimum required version. This is the project name. This is the C++ standard you wish to use. I'm using standard 23, version 23. I could probably use 20. I don't want to use anything lower than 20 though. These find the OpenGL packages along with this line, which finds the include directories. So this just finds OpenGL stuff. Let's see. I can remove that. All of this has to do with just copying the shader folder in its contents to here, so that both on the cmake being run, the cmake list being run, and also when I actually run and compile, when I compile and run the project, it'll run this. Because if I make this, if I like add stuff to here, and then I debug the project, I want this to go into the output. Otherwise it doesn't, then I have to pretty much do that to force it every time, and it's kind of annoying. But yeah, but basically it creates a custom target, and I just run that target as it's a dependency of the main target. So it'll, when I build this, it'll run this. And then this is also to do with OpenGL. It's for the graphics, the OpenGL math, and the GLFW. I don't remember what GLFW does exactly. Okay, and let's pull this up. So, kind of getting started here. I'm gonna kind of copy this. I'm not gonna copy and paste all this stuff exactly though. The thing that I want though is we need to import glue and GLFW, and then actually do something that would be somewhat helpful. And the thing that's great with Linux is always on top is just built in. So, okay. IO streams just here for that. Let's see. OpenGL. We want to include GL blue.h, and then include GLFW GLFW3.h, and should find those. Yep, it does. We can also probably include GLM, though I do not know where GLM is. Yeah, I mean that I could figure that out later. GLM's the math library for OpenGL. If you're wondering where these are installed, I can tell you I have absolutely no idea. Um, Installing is something ChatGPT told me, and I followed it. But basically, you install let's see, did it here already? Yeah. So you run this, and it'll install the dev um library stuff. And actually, I'm gonna copy that. Hopefully that copied, and then I'm gonna make a. Do we have a markdown template here? No. Okay. We'll just make a new file. Where did that not work? A new file, please. Excuse me. Oh, it's hidden. That's right. Ugh. Right. Readme.md add. Okay. Archaea, if I can spell. Um, 3D falling sand simulation. Setup. Let's see. We'll do 3 hashtags and then uh, 2 there. We'll just do Linux. Um, install. I'm a little stuffy right now. OpenGL. Wow, I cannot. Um, sh. Not. Okay. Where's the command? We will always on top u. It is sudo apt install libglue dash dev lib glfw 3 dash dev and libglm dash dev. Hopefully I typed all those right. Libglue dev, libglfw3 dev, and libglm. Yeah. Okay. And then uh Windows install I have it in here. This is basically the Windows install instructions. We can close this. All right. Yeah. Have fun. Good luck. Basically. Okay. Let's add readme md commit. Um. Add OpenGL and shader files. All right. Commit and push. Push. Thank you. Okay. The question is, does it run still? Yes. Okay. We still get hello world. Okay. We're all good. We're all good. I can close that. Git ignore is fine for now. Okay. So basically in here, we're going to need to, I remember, initialize, think we need to initialize, we're gonna need a while loop of some sort. For now, we'll just do that. Let's see, I'll remove this. I guess I can actually just look at this, so we'll ignore that. So initialize GLFW. I believe GLFW handles windowing and like basic input. So like keyboard and mouse inputs. I think That's what it handles. Yeah, so it just handles like the windowing stuff. So what we can do is if glfw init, this runs glfw init, and then init return the value, and if its value is uh false, which means it failed, then we need to basically give an error. So we'll do that. SDC error failed to initialize glfw, and std indel return -1, and hopefully I do not mistype stuff because I kind of can't see. Okay, there we go. Well, we'll get that out of the way. Okay, so this should init and then set an error callback. I guess I should do that. Basically, this is if glfw has an error of sort. We have something that kind of actually prints the error. I'm gonna actually just copy and paste the function. Let's see. So what we do is set the glfw error callback, and then glfw set error callback, and that is error callback. I am not a fan of the naming of this function, so we're going to rename it. There we go. Excuse me. Okay. I did not spell that right. Is there a... No. Initial... There we go. I don't know how to spell. I'm actually curious what happens if I run this. Absolutely... Oh, there's a while. So I guess, yeah, everything seems to be fine. No output in the console. The next thing to do is actually set up the window. These hints, I'm not entirely sure. I think this is hinting to glfw what version of GL we are hoping to use. I'm not entirely sure, but we will do that. Give hints to glfw about version we wish to use. That's just my best guess. Window hint. glfw context version major. Value 3, and then glfw window int. I cannot type glfw context version minor. We want value 3. glfw window hint. glfw OpenGL. That OpenGL profile. glfw OpenGL core profile. Alright, and then actually create the window. Create the window using glfw. So glfw window pointer to window equals glfw. I froze. Create window. Scroll down there so you can actually see, and then I'm actually going to define some constants up here if I can click in the right place. Some constants. So const window width. We'll just do 800 and const int window height 600. Unsigned. I forgot how to C++ there for a moment. Okay. These just want normal integers. I mean, technically it's fine. Window width and window height. Then the title of the window, so Archaea. These are just null pointers. Okay. I would be surprised if we actually get a window. Let's see. Yep, we get a window. It's rendering nonsense garbage that is transparent. Very interesting. You can't do anything. Okay. Alright, we're back. We should be back. Linux just completely crashed on me there. That was interesting. Okay. Not sure why it crashed. It's probably because the window I created wasn't correct. Sorry, Ubuntu is experiencing internal error. Sure. Okay. Let me. Let's do that, and then if I go ahead and just do this, okay. I'm sorry, I'm blinding everyone. Okay, change that for a minute. Okay. Oh, and OBS is being. Oh, there we go. We'll move that there. There we go. Now I can do this. While I open everything back up. Everything closed on me. Linux crashed. Alright. Let's see here. I'll get the display back. Let's get Sea Lion back up. CD. I actually don't know what's here. CD, let's see. Oh my goodness. Okay. Downloads. Let's see. Sea Lion. Oh, it's lowercase. There you go. Oh, I should have did bin as well. There we go. And then I can rerun that. I should be able to close this terminal, or is it gonna close Sea Lion? I don't care. The pattern, yeah, okay, whatever. Yeah, I guess I can't really close that because, you know. Okay, don't run the window yet because, it crashes the whole thing. I'm pretty sure I need to actually free this, to properly close it. Something I want to do first, though, is actually change. It's so bright. Okay. Do I have the theme that I wish to have? One dark. I think I'm used to one dark. I think that's what I'm gonna use. Although it would be nice to have like the JetBrains theme. Is frozen. There we go. Okay, that's a lot better. I'm more used to this. Can I zoom in and out? All right. The value is never used. Right. Okay. Let's open this back up and Control J. We'll hide that. So we need to create the window. Oh yes, right. Always on top. There we go. We need to check if the window is actually if it worked. I'm gonna move my mic down a little so I can actually see. All right. If window, forgot to do that. std C error failed to create GLFW window. There we go. std, I can't see anymore. I need the terminal backup. J. No. Okay. I'm gonna move this over here for a second then. STD and L. Yeah. And then GLFW terminate. That's return -1. Perfect. Okay. And then we need to make the windows. Alright, make the window context current, whatever that means. Make window context current. GLFW. Make context current. And then the window. And then frame buffer size callback. What? I don't know if this is necessary because all it does is this. I guess. I mean, I don't know what it does, which is why I have a to do in here. I think it's something to do with like resizing the window, probably. Again, I don't agree with this name, so I'm gonna rename it. It doesn't return anything. It does call it. Okay. Size, callback. Might chat come back. We're going to step back. No. Let's not download again. Yes, the chat is in fact back. Always on top. There we go. Okay. Where was I? The frame buffer thing. Okay. And then after that, we need to initialize glue. Initialize glue. GL enum error equals GL init. I'm not sure what glue is exactly, right? But that's part of the learning process. Just like GLFW is obviously the window and stuff. Glue is a something. Let's see, glue. Okay. Glue is not okay. So SDCR. I'm basically just copying this, but I want to actually write it myself. Because otherwise, then I don't understand what it's doing. And no, I didn't want that. Okay, failed to initialize. Why is this not always on top again? Thank you. Failed to initialize glue, and then glue get error string for the error, and then error std end L. There you go. And then return -1. Don't we also need to terminate? Pretty sure that should be there as well. We definitely need to make some better error handling. It kind of just takes care of that for me. Shader program. So this is shaders. I kind of have this janky ass shader compiling stuff that does 0 error checking, which is not very useful when there's an error in my shader code. For now, I'm just gonna get to the while loop, and this is let's see, while the glfw window should not close window, and then actually in the while loop we need gl clear, gl color buffer bit. I'm not sure what that value is exactly. I guess it's some color. Set the shaders. We're not doing that right now. We're just trying to get actually a window to come up. We need to swap the buffer. Okay, so clear this window. Do drawing here, and then swap the buffers. glfw swap buffers window, and then pull for events, I guess. glfw pull for events. Okay. And then the cleanup and exit, we need to delete vertex arrays, delete buffers, delete program. We don't have any of those right now. So glfw destroy the window, and that needs to be window, and glfw terminate, and that should be it. And hopefully this doesn't crash this time. Okay, the window functions normally. Oh, the window functions normally. Okay. We're all good. Didn't crash. We're good. Okay. Excellent connection. Thank you. Average view duration 50 minutes. I haven't even streamed. Have I been streaming for 50 minutes? I mean, I suppose. I guess I have. But like no one's watching. No one's been viewing. How is the average view duration that long? That makes no sense to me. Okay. Um Alright. So what I want to do is actually make kind of a game engine sort of um around this. So this is so simple to have a window up and running. Like if this is, oh goodness, if this was in first off Windows and DirectX 11, this would be more than one file. I would have had to make more than one file. This is so much more simple though. So excuse me, I needed some water. I guess, how do you remove this bookmark? Did I click a button that I don't know what I clicked? Delete bookmark, there we go. Okay, so I guess what I want to do is kind of make this a little more reusable. Um, let's see. Yeah. Okay. This should be a resizable window. Yeah. Very basic window. I got the name. We got it. Okay. I'll make a commit. That's probably a good idea. Got a window. Let's go. Yes, I know there's a to do. That's more of a just note for later, not really a to do. Note. I mean, yeah, that's fine. Okay. What I want to do, I guess, is kind of do like, hmm. I'm trying to think about how I want to do this. I guess I can do a class and we'll just call it like app. I figured that's probably good. This is gonna be like our main thing. I am a pragma once kind of person. There we go. Public app constructor. I think I'll just go with, I guess actually I probably shouldn't. The app constructor. We also need the destructor, the deconstructor, or the destructor. Going a little insane there. Okay. I guess also, yeah, with those we need, we'll just do void run. This will actually run like the while loop. Yeah, that should be good. I'm not sure why this isn't complaining. Add to CMake. Okay. There you go. Can I make this go to a new line? Yes. Why do these do that? Yeah. This should still run. It'll probably not complain about the fact. Yeah, there we go. Generate constructor. Alright, definition. Generate. Add. Why not add this? Okay. Yeah, okay, that should be fine. And then, okay. Use default. No, I don't want to. Okay, let's see. Okay, so apps init. Basically, we need to do all the initialization. That's this. We need to include these things. We want the constants and I can basically remove those, and then these can also go in here for now. And then we want to remove that. Include app.h, and then we want to do I don't know if we actually want const. Just auto app equals app, and then app.run, and then it should automatically run the destructor while goes in the run. And then this is all the exit code stuff. And then we're going to want on app.h private to values, we're going to want to store the window on here. This is a pointer, so yeah, fine. Okay. Then do that. There we go. And then I guess I need to figure out how to deal with the error here. Basically, there's an error I need to tell it that there is an error instead of just continuing to run. I could do like void init, int init, and then generate definition, and then instead we move all this in here. And then we can do int code equals init, and then if code we can just make like a int error code, and then we can set that to 0 by default. Error code equals 0 or code. There we go. I don't know what I am doing. There we go. This is complaining because Windows not initialized. Yeah. I mean, it technically is. You just can't see it. That's a problem for you. Yes. Okay, and then if run, if error code, return error code. And then we'll make this return int, and then int, and we will do return app.run. There. This should just work. No, it doesn't. Okay, what is this complaining about? GLH included by before glue. Oh. Probably because in app.h we include that. That should be fine. There we go. Okay, everything works. Let's go. Okay. So, this is basically return 0. There we go. We exit the loop. There's an exception. Excuse me. I close the window. Okay. That's fine. That's fine. Okay. Basically, we need to make, I guess I can make, I kind of want to do this like a little system based, I think. Basically just like a bunch of systems it runs through. And then, that would be a huge joy. So, let's see, if I, include, vector dot h, thank you. Yeah, vector, there we go. I don't know why I can't. Basically, I want std vector of a system. I'm gonna have to make a class, and then we'll just do that for now, and then we'll call this systems. Do I do it this way? I mean, what kind of systems are we gonna have? We're gonna need to render. I guess it's part of system. I don't know. I guess for now, that's fine. New class. We'll call this system base. We'll just call it system. Add to targets. Thank you. Okay. Add in pragma once, and then a public system. Gotta remember how to do derivable classes. If I can remember my words right. I think I do virtual system equals 0, something like that. Let's see, virtual init. We want to be able to initialize the system. Void init equals 0. Virtual void update, and then we want to float dt. Virtual void render, that equals 0. Virtual void exit, and then that equals 0 as well. These are all purely virtual functions. Let's see. I think that's all. You need the init, update, render, and exit. Yeah, that sounds about right. Yeah, that'd be fine. And then if I make a folder called systems, and we'll just call this one triangle render. Sure. This one will just render a triangle. That's all it needs to do. This is derived from public system, and then import public triangle render triangle render override not implemented. Okay. Let's see, void init override void update float dt override void. Usually this helps me out here unless I'm doing something wrong. And then void exit override. And yeah, for now that's fine. Implement, we'll put this over here. No, over here, thank you. Triangle this, triangle that, triangle me, triangle you, let's go. Triangles everywhere. Okay. Systems, main system app cpp app.h, here we go. We want to actually import this class. I know I should probably do forward declaration. It might actually be better, but it's fine. Put that up there. And then let's see. Void add system. And this will take a system pointer system as input. And this will just do systems dot pushback system. Woo! Okay, so if I go to main and do app.add system, And then we do auto triangle system equals triangle render. I know I spelled it wrong. Include systems triangle render. There we go. And add system. For now, because I'm lazy as heck. I guess probably shouldn't do pointer, but I'm trying to think. I mean, I can make a pointer to it like that. There we go. That's probably a better way to do that. Test triangle system. There we go. Get a basic triangle rendering. Let's see. Everything crashes. Okay. Yes, everything does crash. Undefined reference to system. Right. The deconstructor on system virtual. Right. I'm pretty sure I need to triangle render. System override? Come on. No. I'm not gonna worry about it for now. I can fix it later. I fix it later. We fix it later. System H. Let's not make destructor virtual for now. Default. There we go. Does it run? Oh, it runs. Okay. Although we're not actually doing anything quite yet, so we'll move these out of the way. Okay, systems pushback, and then what we want to do in run is for auto reference system in systems, and then system dot init, and then we want to before we clear the window, we want to update, and then we'll pass a float of 0 for now since we don't have DT set up, and then we'll do render, and then we'll do exit over here. Exit. Okay, okay. To test that this is running, we can do std cout. Wow. We'll just print dt std ind l, and then import symbol. And yep, it is working. We got a system. Let's go. All right. Got systems working. The destructor might be a little iffy there, but that's not the point. No, it's not. We won't worry about it. Okay. Oh, we're doing so good here. We're doing so good. Okay. We have a window. We have a very, very basic a system uh thing working. So now I don't ever have to look in this app code ever again. Well, that's a big lie. But let's go. We got a system. Let's actually try to get a triangle on screen now, or some sort of shape, something. So let's see. Should I get a triangle, or should I just be done for the day? I can't be done for the day. I've been streaming for like an hour and a half. We gotta get a triangle. We have to at least get a triangle. But I also want to get ray marching in here. Um, Ray marching's a little more complicated, but if I can get a triangle on screen, that would be great. So I guess I don't need to touch any of this anymore. I just need triangle render. I mean, I guess you should probably get some sort of TT thing going. I'll have to do that later, but for now, um, let's get a triangle. Let's see. We okay, on init. I guess we need to do. We need to load we need to create the shader program. Render, we need to bind the shader program. We need to create some stuff. Always on top. I'm gonna use this. Control J. I think actually, you know what? I might not use this. I will probably use um I'll probably use my learning OpenGL repository. I'm hoping that when I got a triangle, I pushed a commit rather than just jumping straight to stuff. Okay, 11 commits. Let's see what we've got here. So, understanding ray marching, full screen rect using index drawing. Okay, yeah. So we have a hello triangle example. Let's browse the files, and this is all just in the main file, so there's not like jumping between files. Yes, let's go. Okay, so I have a basic thing that just reads a text from a file. That's so I can read the shader file. Um, this compiles the shader and creates the shader program, so it returns that. What we need to do is create the shader program. We need the vertices. We need to generate the buffers, bind the vertex array, find the buffer for the stuff. Yeah, I'm a little lost on these, to be honest. I guess I can actually think about these. VBO and VAO. Why? Okay, so generate vertex arrays, generate buffers, interest, array buffer. So this all can be done in init. You only need to do it once. Create the shader program. Move this over. We'll. Am I not always on top of this? Oh. Oh, here we go. Okay. Make this a little smaller. Maybe not that small. because I want to actually be able to see this. So we need to create the shader program. Um, find the vertex buffers. We'll say generate and bind. Then update. We don't need to do anything right now. I mean, I guess no, it's not really rendering. You need to so set the shader program. I'll say set the shader program. Uh, bind the vertex data. And call draw. Okay, that's pretty simple. So the thing to do is I'll probably want to make a separate function or other or something that handles shaders for now, just to get stuff rendering though. I don't care. I'm actually just gonna copy this, the read file. I just want to get this working and then we can clean it up kind of thing after it works. Like make sure, like I know this code already works kind of thing. So like actually um make sure that it works and then clean it up and continue to go on about life. Triangle render.h. We're gonna want a GL in here. So private variables that we're gonna want. We're going to want the GLU int, the shader program. We'll initialize that as -1. Yeah, okay. That's fine. We need the, I guess we're probably gonna want these. The vertex buffer and stuff. I guess we only need VAO. I don't even remember what VAO is. VAO is bind vertex array. Um, right. Okay. I think that's all I need then. Yeah, that should be fine. So in triangle render, move this, so I don't get confused. Compile shaders. This might need to be, no, wait, this is from, yeah, okay. So init, I guess technically init could be in the constructor, but for now I'll just have this. I mean, perhaps init should be separate actually for purposes of like initializing stuff that's after the app is initialized or so. I mean, yeah, whatever. Okay. Okay, so shader program equals compile shaders. I definitely need to add error checking to that. Then all of this, so float vertices. Do I need vertices again? No, it doesn't look like it. interesting. Graphics programming continues to kind of confuse me. We will do negative 0.5f. Negative 0.5f. 0.0f. 0.5f. Oh, I forgot a comma. Negative 0.5f. Why added a space there? 0.0f, 0.0f, 0.5f, and 0.0f. Okie dokie. Are these all lined up? Not really. Why aren't they lined up? Okay. Let's see. So GL, covering it. Oh, GL gen vertex arrays. One, and then reference to VAL, and then GL gen buffers. One. Oh, this is okay. So how many to make? And we only make one, so one vertex buffer and one vertex array. Interesting. Then GL bind vertex array. And move this and actually see without being covered. And then VAO. Alright, I'm gonna take a break really quickly. Just to like drink water and rest my voice. So I will create a text thing. Oh, hello, hello, hello. All right, I'm back. Rid of that. I'll move that and turn it back on. And then if I hide the display, there we go. There we go. Okay. Anyways, back to programming. Okay. So where was I? GL bind vertex array. Right. Okay. Then we need to GL bind buffers. GL array buffer of VBO. Why did it do that to me? Like tab, not. GL buffer data. So we need to set the buffer's data. So GL array buffer. Size of vertices. The vertices themselves. The GL static draw. And then make this a little wider. Okay, next up we need to bind the vertex attribute pointer. Whatever the heck that means. GL vertex attribute pointer. Let's see. The index 0, the size 3, GL float is type. Is it normalized? No, it's not. The stride, so 3 times the size of a float. There's a float. Okay, so float 3s, and then const void pointer. I mean, okay, yeah. Void pointer 0. Okay. GL enable vertex attribute array 0 for index. GL bind buffer GL array buffer 0 for the buffer. GL bind vertex array 0. Okay. Then in render, we set the shader program. So we do GL use program on the shader program. And then, let's see, we GL bind the vertex array VAL. And then we actually call the draw function. So we actually draw GL draw arrays. GL triangles. Uh, 0 and 3. First and count. Who knows what those mean? And we should get a white screen. No, we get a crash. For some reason or another. File. Oh, I need to include these. That might help. We should get a white screen. Okay, a black screen. That's fine. Something that's blank. Failed to open shaders fragment. Oh, yeah, okay, I see. We're gonna rename this fragment. Refactor. Okay, there we go. Now it actually opened. But we still don't have anything. Why? Well, because I haven't actually added anything to the shader. um, so the vertex shader should be easy. We just need the version 330 core. We need the layout location equals 0. This is an in variable, which is vec3 a pose. That's the vertex, and then we want to output a vec4. Let's not output anything for now. Let's no for now. Just void main. Thank you. We need to do GL position is a vec4 of a pose and 1.0, and then yeah, that should be fine. Oh, we might get nothing, we might get something. Okay, then we need to do fragments, so we need version 330 core, void main, and we need to do an out called, do you set the output yourself? Yes. Need output. We need output of vec4 called frag color. So this is the color we output, and we can just do frag color equals vec4 of, I don't know, 0.5. Let's just test if it's even working. Oh, look at that. We get a triangle. Let's go. Okay. This is a triangle's color. I see. So if we do GL fragment chord as the color instead. So that's very interesting. This wasn't expecting yellow. Okay. So if we want to do this, we can do out color, out vec3 color, and then if we just set color equals a pose, and then in fragment we just say in vec3 color. It's gotta be the same name, and then we can just do color and 1.0. We should get the somewhat classic triangle. Yes, let's go. We got it. We got a triangle. And everything's working. I mean, look at this. This is so fast. It took me days to get a triangle on screen with DirectX 11. I mean, I was also following a tutorial, which also kind of makes like a maybe a larger scale, more complex game engine. So I was also trying to follow that, but like still, it took me days. This only took me like 2 hours. Yeah, about 2 hours. That's not too bad. I mean, not too bad. I'm getting better at this. I still don't understand a lot of the code, but I mean, this is a good starting point at least. Do want to kind of not use as much copy and paste now. I mean, I'm not really copy pasting too much, but like All right, so what do we need to do to get ray marching going? So ray marching is done completely in the fragment shader. Um, so what I need to figure out is how to pass in an array of some data to the shader. That shouldn't be too hard. Then I need to figure out how to actually use that array of data with the ray marching, and then actually getting ray marching working, which actually isn't too hard. So the first thing to actually do is just make the rect be full screen instead. That's not what I wanted. I still had this open. So instead of just a triangle, we actually have a like full screen rect. And I mean, technically, you probably get away with doing one triangle and just like sizing it big enough that it like covers the screen. But I feel like that requires some extra work that I don't really care about. It's like you're gonna get like a little bit more performance out of it for just one less triangle. It's like we're only rendering two triangles to render the entire thing. It's like that's not bad. I mean, if I run this, this should still run. Like if I run this, which is me messing around with ray marching, let it load. This is only two triangles. There are only two triangles. It's this one and then this one. This is all just the pixel shader. So that's the fun thing here is yeah. So I'm gonna actually have this open because I kind of want to mess around with stuff. Um, I guess the first thing would be kind of following this. Um, the thing that we want is to use an indexed vertex buffer, which looks like you only need to add like one more thing to all of this disaster. And then this is me trying to do something else. Don't not necessary. Uh that's not necessary. This is me putting them setting the mouse pose variable into the shader. This gives it time and the resolution of the window. Let's see. I guess all you need yeah, I guess we're gonna do this using indices so that way I don't have to type out all uh like a bajillion of these. um so I'm just going to copy and paste because I don't want to type all of that, I'm gonna be honest. So if I go in to triangle render and just replace, actually, let's make a commit. Triangle, yay. Commit and push. Before we like mess more stuff up, you know. Okay, so let's do this. So make sure this runs. Yeah, okay, we get nothing. Because what we need to do is this and the draw. So that's fine. Yeah, we just need to do that. And then that should draw a full screen rect, but it does not because I probably missed something somewhere. Swap buffers, uniform. We can probably do these as well. I don't have ebo. That's part of an issue. Triangle render H. We need ebo. There we go. There we go. Did we use? No, it's just. Who knows? Oh, because this wasn't being set. That's why. Okay. So. Really? Full screen rect. Now it's time to do some, you guessed it, stuff. Okay, actually what we need to do is pass in the resolution. So I'm going to just do this, give it resolution and time so we can actually get some movement in there and whatnot. Right, we're going to need the window. How do we do that, you may ask? We could pass it in. I'm pretty sure I'm only gonna need the window for rendering. I could. Yeah, we'll just do this for now. It's not the best option, but it works. So we'll do that. Then we need to go to system render, add the window. We need to import GL. And then on app, we need to, when we call render, we need to pass the window variable. There we go. Okay. So now we are passing a constant to this. We can do in vec2 resolution and in float time. And this should work. Make sure it works. Yep. Okay. Pass resolution and time to shaders. Because I'm pretty sure you can also access these in here. Actually, I don't think uniform is the more appropriate word. There we go. That should be proper. So, in here, to get started on the ray marching, what do we need? So, we need to... We need the camera position and some other stuff. Okay. Going insane, going insane, going insane, going insane. Actually, how loud am I? Because I might need to adjust my volume settings a tad bit, or I might need to talk louder. So, we're going to check. Yeah, I'm very quiet. Yeah, I need to turn up my audios a little. I have sound max in OBS. Can I turn up my oh, that's way too loud. Okay. How about that? That good? Maybe that. There we go. Then I'm not too loud, but that should be better. Yeah, let's test. Hopefully my mic's not clipping, and hopefully I'm not too loud. But then if I talk a little quiet, then you can hear me still. Yeah. Love testing audio settings. Yeah, that should be good. That should be good. All right. Yeah, mic is just a little too quiet. We'll turn it up just a tad bit. Let's see. Okay. So the basic idea of ray marching, I kind of forgot the first line of math. So I'm gonna pull this up. Um, okay, so you kind of need these bits of math. So you need like the camera position, then you make arrays, the ray and stuff. Um, there's a few ways to do ray marching, and I'm just going to start with the simpler way. This is a little more complicated. So this is the output color. We're going to start with this. So basically you have, this is kind of just like the camera positioning and stuff. Basically you create a ray for every pixel on screen, and you go from there. Ray position probably be fine starting the camera somewhere like here. We'll start there. Then the basic idea is you have a for loop. So int I equals 0. 0 is less than some amount, and then you plus plus, or not 0. I don't know what I'm thinking. I'm gonna do a const max steps, and we'll just do 80 for now. That's plenty of distance. Int, there we go. Max steps, and then there. So we're gonna need a function that returns a float. We'll call this the scene, and we're gonna want a vec3 ray. We'll just call it p for now. And then for now we will return 0. Then in here, basically we're gonna want a float total distance of the ray. We'll set that to 0 for the start. Let's see, we're going to call the scene, there's a few steps before that, but the scene, we want the ray pose. There was something you do with the ray, it's like vec3. We'll just call it ray pose for now. I think you multiply it by the total distance, then the distance of the thing that you have, then you total distance plus equals that, and that should work for now. There was something here, there's another thing to multiply or something like that. This needs to be p. I guess I'm pull up the shader toy demo, but this should just do nothing pretty much. Actually it should give me just the As color doesn't exist. Or no, it does. This. So what have I done wrong that has caused it to crash? Okay, I guess it was that. I don't understand shader. I guess I should really add error checking. That would probably help a lot. So basically nothing happens right now because all we're outputting is just the colors still. We're not actually outputting any of the data here, but I do want to actually make sure that I've done this properly, of course. So, let's see. Let me pull up the commit history. Insberr learning OpenGL. Hello triangle. Ray marching. Yeah, okay. This is all just a bit of shader magic. So many chromes open. Okay, yeah, so what we need to do is the ray origin or the ray position plus the ray direction times the total distance. I got this, the scene, the total distance, and then we want to add actually an if condition to stop early, but we will do that later. For now, it's not quite necessary, only just because I'm kind of lazy. What I can do as well is make a color vector, so vec3, I'll just call it color, equals vec3 0. And then this will be color. And then what we do here is set the color equal to a vec3 of the total distance times some arbitrary number. We don't care what this number is necessarily. And we should just kind of get nothing because, well, we don't have anything in the scene, and so nothing really happens. So, alright, let's add something to the scene now. So, let's add a cube. So we need to do float cube SDF. I have no idea what the math for this function was, so I'm gonna have to look it up. Vec3 point, and then yeah, vec3 size. So this is the dimensions of the cube. So we need vec3 q equals the absolute value of point minus the size, and then we return the length of some large equation here. The maximum of q and 0 yeah, plus the minimum value, that is not a plus, plus the minimum value of the maximum value of q dot x the maximum value of q dot y, q dot z, print c, and compared to 0. Okay, so that should be a cube. What do we do with this? So, in our scene, basically all we do is we return a colorless function with passing in the p value, which is our array, and some random value. Yeah, not random value. Just the size of our cube. We'll just do 0.5 for now. That works. Do we get anything on the screen? Okay, something's not quite right. Either I messed something up, or I guess it would help if we actually had the break here. So we can do something const float. So max distance 100. So this is the maximum distance that the ray can go, and then the const float surface distance. This is how close to the surface of the end of the ray is to the object is counted as a collision with it, and this is a pretty good number. We can also add a field of view. I'm going to make it 0.7. That is a float. There we go. And then we want the field of view. Interesting. Field of view gets multiplied with the UV values of the ray direction. You know what? I won't worry about. Actually, I can just do ray direction. Nah. Too much thinking. Anyway, we want to add an if condition here to break. So if our distance to an object is equal to the surface distance, we want to break. Or if the total distance traveled is greater than our max distance, we also want to break. We'll see if we actually see anything. So it's still white, so there's gotta be an error somewhere. Something's not to correct right. Probably like a spelling error or something somewhere. Vec3q absolute value point minus size. Cube's position 0, 0, 0. It might help if I just use these simpler camera position stuff. So let's remove that. And then array direction and position. So ray origin and ray direction. There we go. Yeah, so now we have FOV back. We'll go 5. Still not working. Somewhere I have messed up. Oh, I didn't mess up. I just can't see it very well. But yeah, there's a cube right there. I really need to add error checking in this. We really might want to move a little closer. There we go. Now we can see. I don't know why I decided to be so far out, but basically we have a cube. We are only seeing it from one direction, so I don't have the mouse in here, do I yet? No. Let me get the mouse position in there. So all I need is this. And vote here. Triangle render. Pass in the mouse. SD ranges clamp. There we go. This should pass the mouse. And then we can do uniform vec to mouse. We kind of need to do the same thing here. So vec to mouse is pretty much all of this, but mouse. Is it though? Ray marching, understanding ray marching a little better, sure. Do I have a mouse input here yet? No. Ah. Here we go. Okay, mouse. We're gonna want a rotate function, so I'm just going to copy that because I don't want to type it all. Make sure everything runs still. But yeah, if I wanted to rotate, I could do p equals rotate 2D times equals rotate 2D p dot xy. We can just do time. So it should just rotate with time. Yeah. We can do a different axis as well. Yeah, so now we have a cube. And you basically this is a depth buffer. As you could say, is how we're rendering the color. Would be nice to invert the color. Anyway, we can make a mouse sensitivity float. So if we do const float mouse sensitivity, we'll do 4.0. And then what we need to do to get the mouse to work is this. Basically, I want to make it so where the mouse position is, it kind of just controls the camera position all through the shader. Later on, all of our position stuff will probably be handled on the CPU side and then just passed in here, and we just pass in a camera value that we just straight up work with in here. But mouse.xy we just do times 2.0 minus the resolution.xy, and we divide that by the resolution.y and multiply that by the mouse sensitivity. Then in order to actually make the mouse movements, what we need to do is manipulate our ray origin and stuff. So ray origin dot yz times equals the rotate 2D and negative mouse dot y. So let's see what happens here. So yeah, so the mouse does rotate, kind of, but not fully. So we need to do ray direction dot yz times equals rotate 2D and negative mouse dot y. And then things should be, yeah, that's a lot better. So things are a little less weird. So there's no X rotation yet, but there is this way. So even if we made this full screen, it's so bright. It's so bright. Okay. Then if you want to do X movement, it's the same. We do want to make sure that we do the vertical movement first. So, vertical movement, and then this is horizontal movement, if I can spell right. And we just change this to X and this to XZ. And run that. And we can move our scene around just by looking, which is pretty epic in my opinion. Another thing that I can implement is fract, which will basically render a whole bunch of cubes. So, I guess the thing I'll do first is create another thing in our scene. So I'm gonna remove this or things that let's make a floor. So we're gonna call this ground, which just equals p dot y, and then we can lower it a little bit. We'll just do 0.75. That should be fine. And then how we actually combine these, we do the minimum of the two distances. This stuff has me a little confused still, but it's fine. So basically we have a ground now. The closer to it we are, the darker. We can actually probably invert the color or invert our depth buffer here. So basically, color ray march. Trying to find my code here that worked. Okay. Trying to think of how to invert the color. Be total distance, max distance minus the total distance. Okay. Yes, but things are a little interesting. Probably because this needs to be 1.0 divided by, because otherwise everything's just blasted white. Okay. We get the outline of stuff a little bit. It looks quite interesting. Not quite what I was intending. Okay. I mean, yeah, basically I'm a light now. Okay. Yeah, that's a lot better. We can see our depth. Basically, the brighter something is, the closer we are to it. Yeah, that's pretty good. Things are very dark though. Okay, that's sort of better. I'm going to actually leave this at what we had it before for now, just because our effect becomes kind of mysterious looking. Okay, something I fix because this is happening if I go on the floor, basically. Something I actually did is setting the ground. Basically, if the ground value is less than negative some very small value, that's probably a bit small for the needs, then we set the ground to the absolute value of itself. And basically it makes the ground a little more like a plane instead. So if you basically go into the other side, it's like there's two sides of the world. How weird. But yeah. Okay, so the next thing to do is actually with the cube, I'm going to move you to your own value. So I'm going to do float cube equals cube SDF and then cube. something we can actually do is use the fract function with the cube. So if we do vec3, we'll create a new a copy of the point, and we're going to fract that. So fract p, and then we need to align it by some amount, and then actually pass in q, and we're going to get a whole bunch of cubes on both sides of the world. But look how cool this looks. I mean, the closer you are, the darker it is. But you get this like weird fog. This is quite interesting, actually. But yeah, this is our rendering. This is all the pixel shape. None of this has anything to do with C++ code. Well, none of the cubes at least. But look at this. This is all just the shader. And make this bigger too, so we can actually get in on the action here. If you go into something, it is a little weird. Yeah. So this is probably what I'm gonna be doing. So the thing with this is that it's probably not the best way to render lots of cubes right now. Or I guess is not really what I mean. It's kind of weird that things kind of touch the ground, or they like smoothly go in. I think that can be fixed though. So if we just change this value, basically this is a value we'll probably want to tune, but it's basically how fine the details are. So you can see if I'm closer here to the floor. It's quite interesting. Things don't seem to get consumed as much. Basically, we make this as small as we wish, although smaller might not be better because it does mean more processing. But it does not seem that that fixes itself. It's just kind of an interesting value. But like if I make this 0.1, things will be very low resolution. Actually, they look very funky. Like this actually looks pretty cool in my opinion. But this isn't really what I'm intending to have. But yeah, you can see things kind of fall apart a bit, you know. Just we can also increase like how many steps we do. So instead of 80, we can do 100. This is just how many times the ray is actually gonna step. So I'm gonna change this back. This is a pretty good starting value there. The maximum distance is just how like far a ray is allowed to go before it's like, you shouldn't exist. Oh wow. What value did that? I guess that would be the steps. So we can only see like very close to us. So if we go back to 80, which is probably fine for our needs. Yeah, everything's clear once again. It is interesting though that the cubes kind of get consumed into the ground in the distance there. But that is just the ground, which is interesting. The cubes don't combine though. It is very interesting, but and also max distance, yeah. We'll just stick with 100 though on the max distance. So now the thing is there's the ray marching I'm using in this, which if we run this is using somewhat different ray marching. But basically if it hits anything, it makes a voxel. That's kind of the idea of it. So what's nice about this is it actually makes it easier to kind of deal with voxels, because you kind of just every ray step, it steps through a voxel amount, so it's just a full on voxel position every step. So that's ideal for what we're doing, because then if we pass in some array of our voxels to the shader, we can just index that with the position or some, if it's like a 3D array. And then it works, It doesn't have to be anything fancy, but that is where things are a little more complicated. So I'm actually going to copy this. We're going to go ahead and push ray marching, yay. It's not a very informative commit message, but it's good, it's good. What I'm gonna do is paste this, and this is from a online demo, which I guess I should probably make sure is credited. Most of that kind of got code copied and modified from. Basically, it's from this shader toy here. Now, the thing is that I modified a few things. First off, some of just the code I'm not going to use. Which is so there's a branchless DDA, which is basically all this, and that's what I want to use. So there's no point in having all of that, basically, and nothing changes. Now, my main problem is the fact that if I main image, oh, get voxel, that's right. If I get rid of the sphere, it's one of them. Min. Okay. Make this 3. Yeah. Okay. If I get rid of this sphere in the minimum, you can see that. Well, basically, this is the max ray distance. So if I set this to like 100, you might be able to see it change. If I set it to like 1,000, it might be a little more noticeable. Basically, if a ray hits the max ray steps or whatever, if it stops and it didn't find anything that it hit, it basically then hits. Basically, just when it hits, it stops. And that stopping position just becomes a voxel. The other thing is with this that I liked is the fact that it actually has the side of the voxel, so you can probably do a little more like shading stuff with it. Although I guess I'm probably just gonna leave it at whatever this shading is. But yeah, that was a problem that I was having. So if I do like 20, this will be like, yeah. Basically though, this is a problem I was having. And that is something I fixed, and it's basically just adding an if check in here and being like, did we actually hit something, or did we just stop at the max distance? And if so, we stopped at the max distance, don't actually render a voxel because there wasn't actually a voxel there. The thing is that I also changed is instead of this being a continue, it's a break because, well, we hit something, we just want to be done instead of keep going. I would change this to a continue later if and when, well, it's more of a when I add transparency, then this will be a little more complicated, but for now, so if we run this, it should just work. Yeah, so now we have basically what we had before, but without that problem. So what I ended up doing, I guess, first off, I made a scene function. It's basically the get voxel. Wait, really? Did I actually paste that in? Oh, there's still my old code. I see. Okay. I added in iterations, so I know if how many iterations we actually go through. So that way in here, I'd be like, if our iterations is the maximum amount of raise steps, then we actually didn't hit anything, probably. But like, if we actually did hit something, then it's just one less raise step in our range, which is pretty easy. We just, go in and change our max raise steps, which is somewhere. There's a lot of functions in here that aren't actually used now. So the thing I want to do is kind of add that into my ray march. I also want to just get rid of some of the stuff in here, but basically, my ray march function was to actually return the color, so that way I can just handle all the color stuff while I'm ray marching instead of kind of just dealing with it here. So that's, I guess the thing is to actually clean this up, but also figure out actually how to get like actually index the voxels. So the thing is with right now, this is actually a sphere, like an actual sphere, but because of the way this works, it's basically voxels through the sphere, which is kind of interesting. Are you able to create like a const array? Because then I can at least try to do what I'm doing. So if I created like 3 times 3 times 3 int array. Let's see. Let's pull up the lovely old the chat GPT. This is a question chat GPT can probably answer for me. In GLSL, how do you define a const int array? Let's see. I'm sure you'll know what I'm talking about. Constant my array. Okay, yeah. So you just do this. This is pretty much what I needed. Equals. Then they need to be the same size. What is this complaining about? Left operand assigned expression is not L value. Const in. Oh, I need a name. Pixels. There we go. And then this needs to be 3 by 3 by 3. So hopefully I can do new lines. We'll just do 0, 0, 0, 0, 1, 0, 0, 0, 0. Yeah, that should be good. We need to figure out how to 3D index array because I'm not good at that. see. We'll do int. Okay. Let's do the pixels. We want int val equals pixels, and then we index it like this, but it's c.z, the y size, which is 3, the x size, which is 3, and the x size, which is 3, c.y, c.x. Okay. And I'm going to take a quick break because I'm hungry, so I will be right back. Hey, all right, I'm back. Where were we? Oh yeah, we were indexing pixels. Okay, we get a black screen, so we've done something wrong. But what? Actually, no, maybe, yeah. No, I didn't change anything. This line? Make sure. Is it that? Okay. Something is wrong with this. Int pixels. Is something else already called pixels? No. Let's just call it data. Just to make sure. Okay. I'm guessing it doesn't like the new lines that I've given it. Nope. This is quite interesting. GPT, you lied to me. No, I didn't. Let's see. Do I have a Chrome tab open? There we go. Oh, I closed it. GPT. We need you. Indicates the size. Does it have to be an actual like constant value? 3 times 3 times 3 is 9. Yeah, okay. Okay, so we need the value. Oh. Okay, we get something there. Oh. When we pass through. Interesting. So val is less than 0. Oh wow. What have I created? Very interesting. Okay. So we've got something. Okay, the thing to try then is if we want to add a top value. No. Interesting. This is very interesting. Oh, wait, now it's all red again. I didn't change anything though. Unless I accidentally removed a 0 or something. Okay, we get nothing. Hmm. Oh, but does this, if the array range is out of range, that makes any sense. So if C is greater than IVEC 3, 2, return false. And then we do X, Y, Z. Interesting. Can I get rid of the camera rotating? Let's see what's going on a little better. Interesting. Something not quite right. Ooh. If the value is less than 0, then we have a problem. Okay. Interesting. Let us add back in why does that change what I was seeing? That was really weird. Alright, let's add these back. Interesting. So we add one right next to it. This is, yeah, just to the left of it. That's what we should see. Oh, whoa. Why does it do that? That's interesting. That's not what we want exactly. If I do another next to it, if we do one over here. So this isn't really 3 by 3 by 3. 3 times 3 is 9 times 3, which is 27. 9 times 3. Yeah. I can't believe I had to look that up. So we need 27 of these. My guess is this is fine. Maybe. Okay. Yeah, that's a 3 by 3 by 3. Yeah, let's go. So we have a 1D array that hopefully doesn't do that weird thing I kept seeing. We'll just start it a few times. I'm not entirely sure what was going on. Oh, it was probably indexing out of bounds. So this is these are in terms of depth, I guess. So if I do, there's something in the center, and I guess what I'll do to make my life easier is not rotate. Okay, so we'll add one in the center, and then for this one, we'll do ones in the corner, but not the center. Like that. And then this one we'll do ones on the edges. So then we know which surface is which. So we are currently facing the surface that has just one. Also, the thing is with the coordinates is this is split in half because this would be negative coordinates. All right, we're getting there. We're getting there. Okay, if we add our rotation back, okay. We'll just take a quick screenshot of this.